now.
Okay.
All right. All right. So good afternoon, everybody. And I want to welcome you all to SpecterCast. It's our monthly podcast series at the Arlen Specter Center at Thomas Jefferson University in Philadelphia. So this podcast is where we have experts talk to other experts, basically, on various things considering general and topical interests. So today, I'm your host. My name is Marlena Washington. I'm an assistant professor of chemistry in the College of Life Sciences at Thomas Jefferson University on the East Falls campus, and I'm your host for today. And so this particular podcast, we're going to be talking to Dr. Nini Rao. She's one of my good friends and colleagues here in the chemistry department, and we're going to talk about what's brewing, the chemistry of coffee. And so just a little bit about Dr. Rao, just so that you know, she is a professional and she is an expert in her field. She has a bachelor's degree in chemical engineering from Cooper Union, and then she went on to pursue her PhD in physical chemistry at Florida State University. And she's a computational chemist by trade and by her training, but she started to, I guess, get a little bit involved in thinking about artisanal foods and beverages. And so her research has expanded now into the field of food sciences, specifically looking at the chemistry of cold brew coffee. And so that's the topic for today. So Nini, how you doing?
Good afternoon, everybody. Thanks for having me. I'm doing great. I've had my coffee this morning and I'm ready to talk your ears off about coffee.
Nice, nice. And I should preface this whole thing and just say, I actually don't drink coffee. I love the smell of it, but I don't drink it. It gives me too much hyperactivity and then like I crash immediately. So I'm here to learn just really about the whole aspect of the science behind it and the chemistry behind it and how the general people would really have an advantage of looking at this particular type of subject matter. So just a few questions for Nini. So let's start really at the beginning. You're a computational chemist. You worked in inorganic molecules and things of that nature, but you're doing coffee research. How did you get interested in coffee research?
Well, I love food. I would call myself a foodie, and I do enjoy coffee. I think when I was an undergraduate, I kind of drank too much. So there was a period that I wasn't drinking a lot of coffee at all. This whole project started because I started going to California, of all places, and then started drinking a little bit more artisanal coffee, one of them being cold brew. The first time I had it, it was at an American Chemical Society conference in San Diego. And I was like, oh my God, this is such a lovely drink. And I read a little bit about it and I realized, oh, it's not too difficult to make at home. Let me try to recreate that at home. It didn't turn out very well. And then at the time, my colleague and my collaborator, Dr. Megan Fuller, was in the lab doing some work with separation science and whatnot. So I kind of grabbed her and then asked her if she would like to help me create coffee at home that is delicious. And then that's how we started. And then when we first looking into the coffee research, we realized there's not that many research out there that focus specifically on cold brew coffee. So we kind of stumbled upon the field.
Okay, nice. So it was just kind of happenstance, which happens a lot in science and research. You go one way and then end up a different way. It happens to us all, so I understand that. So a little bit, how does chemistry and coffee relate to each other? So I know like they both start with C, like, you know, carbon, chemistry, coffee, all those good things, right? But can you like give us a little bit of a non-technical type of way of explaining how chemistry and coffee really go together though?
So actually, coffee extraction itself, the process of brewing coffee is very much a chemical extraction process. So we are pretty much drinking chemicals extracted from coffee. So one of the biggest things people ask me is, oh, what is the caffeine content, right? We drink coffee because, it gives us energy. It makes us alert. Well, caffeine is a chemical, and then we remove the chemical from the beans to the water so we can consume it. And that's chemistry. And the other thing about coffee is the roasting process. People talk about the aroma, people talk about the taste, and people talk about roasting beans. One of the things about roasting is when you apply heat. Basically, roasting is nothing but cooking beans at high temperature. When you start roasting beans, you start chemically altering the composition of your beans, and you either destroy some of the chemicals, at the same time you create other kind. So the balance throughout the roasting process is what gives the coffee the distinct aroma. And so that's how chemistry is related to coffee.
Nice, nice. So it's not just, the coffee itself, it's really what you're extracting, and
Exactly.
everything in life has chemistry around it. So it
Absolutely. And then we also talk, this is not, there are other parts of the beans that we can talk about. It's not just caffeine. We can also talk about the health benefits. For example, coffee has a high antioxidant content. And there are a lot of research out there trying to identify these compounds, and we consume. And very often you read in pop culture that coffee is a good source of antioxidant. Again, that's chemistry. And then there are other flavors are chemistry as well. So everything about coffee is evolved around chemistry.
I like it. That speaks to my nerdy little heart right now. So I'm enjoying that. So your research has been published. It's garnered some attention in different outlets and things of that nature. So can you explain what you actually found in your chemistry research? Like, what did you actually discover in a non-technical type?
There are a lot of research out there about coffee in general. We focus specifically on cold brew coffee. So for those who are not familiar with cold brew coffee is an extraction method that basically brew coffee at room temperature or lower. Very often, if you go online, look for a cold brew coffee recipe, you're looking the instruction very often asks you to brew coffee either over the counter for 8 hours to 10 hours, or they ask you to do this in the refrigerator for 24 hours. So it's a low temperature extraction process, very slow, compared to, let's say, a French press, which you can do in 3 to 4 minutes. So the cold brew coffee is also a very trendy beverage, very popular in the last 6-7 years, starting in the early 2010 or so. So there's very little research done on this particular process. What we're looking for is to provide some information or scientific information about the extraction process itself, so that consumers like myself can create cold brew coffee at home, or can choose their beverage based on some sound scientific data. So what we started was to look at exactly how the extraction process works. Because the process is so slow, we actually can monitor the concentration change. So basically how much compound in the solution throughout time. And what we found in our first paper was that this extraction process kind of plateaus after about 7 hours at room temperature. So what that means is, if you let your coffee sit for 24 hours, you're not going to get too much caffeine, or the other compound we looked at is called chlorogenic acid, which is a type of antioxidant. And for these two compounds, you're not going to get any more out of it after about 7 hours. So that is something good to know, because if you were to brew coffee and that's what you want to do the first thing in the morning, you can make your cold brew coffee before you go to bed. And then next morning you filter it, you have a delicious cup of coffee waiting for you. So that's something I thought it was very useful. So that was the first one. And the second one, what we found was we decided to explore, to take a look at coffee from various regions of the world. We bought coffee from local roasters, and then we tested the antioxidant capacity of these coffee as well as the acidity of the coffee. What we found was that the acidity of hot and cold are not in this particular study. I have to frame it in the study itself. In this particular study we didn't see any difference between acidity between hot and cold beverage. What we did find was the antioxidant of hot brew coffee tend to be higher than the antioxidant content of the cold brew coffee. So that was very interesting. So we know that if you are looking to drink coffee as a source of your antioxidant intake, maybe drinking hot brew coffee is the way to go. So that was very exciting for us. But we also realized that our research, the method was somewhat flawed because we bought pre-roasted beans from various sources. And then we realized that roasting is a huge factor in the outcome of the coffee. So when you're roasting beans through different methods, you will end up with a different degrees of roast. You will end up with a slightly different chemical composition. And this is compounded by the fact that we are sourcing beans from various locations. We're talking about, Mexico, Colombia, Brazil, and Ethiopia. So all of these growing conditions also change the chemical composition of coffee beans. So for our latest study, we decided to roast our own beans. So we wanted to really control the process, to really understand exactly how the extraction process works. So we roasted our own beans at a different degree from light to medium to dark. And then we grinded our own beans. We sieved the beans so that all the particles are fairly uniform. We got rid of all the fine powders. And then this study, what we found was, number one, hot brew coffee tend to have a slightly higher acidity than cold brew coffee. Slight, but not. But it's different. It's the difference is noticeable. Number two is that again we found a difference in antioxidant content. And then the most interesting part that we found in the last study was the content of the antioxidant content and acidity content tend to vary with roast. So we're talking about a lot of antioxidants being destroyed during the roasting process. And then so the difference seems to be greater when you are compounded with the extraction process temperature as well. So this is one of the biggest find we have, and it's interesting for us to start thinking about brewing coffee not only with the method that you're doing it, but also the roast that you choose.
Mm-hmm.
So
yeah. The light versus medium versus dark aspect of coffee beans and the roast is going to have an impact on that as well then.
Yes, absolutely.
That's interesting. So that's why it's always my favorite time in the lab when you're like roasting and doing the coffee, because it smells amazing in the lab most of the time. So
it's a fun, it is very gratifying to understand the entire brewing process from roasting to brewing. I do want to clarify a few things because as a scientist, we do everything with a protocol. So these protocols may not be something that is designed for consumption, right? So, so the results that we reported here has what we called a fixed grind to water ratio. If you are one of those coffee aficionados, you are familiar with the grind to water ratio. Very often they suggest a ratio of 1 to 15, 1 to 17, depending on what kind of beverage you're trying to create. We are doing 1 to 10. This is not something you would consume, but it's a typical ratio for cold brew coffee. Since we are focusing on cold brew, we tend to stick everything on the cold brew side.
I'm glad you gave that disclaimer because I can see now everybody's going to go home and start roasting
Oh,
their own
no.
things and extracting and stuff. But I'm glad you also said we do this in the lab, right? And so
Yes.
when you say this, right, there's
Hmm.
an aspect. We're on East Falls campus, and that's a primarily undergraduate campus. So you have undergraduates working with you during this, right?
Hmm.
And
Absolutely.
how does that work with them? Like, how do you find them, or how much do they work and stuff?
Oh my God, they are the best research assistant that I've ever had. These students are pre-medical science and chemistry major. And I also had a couple of health science students working for me for some of the other projects. They are very dedicated, and then we came together because everybody loves coffee.
Mm-hmm.
And when we're talking about, oh, I'm studying coffee, all of them were like, hey, can I help? What can we do? And then we started by simple things. Let's make coffee together.
Mm-hmm.
But it's not as simple as you think it would be, because we have to make sure that our procedure is repeatable.
Mm-hmm.
So we have a lot of variables we have to control, but they're all really great and the detail oriented, and then they take notes. We were able to produce some very precise results at the end. And then two of my undergraduate research assistant actually had their name on two separate papers that we published very recently. So it's very gratifying.
Very nice. Yeah. I mean, that's one of the things for us doing undergraduate teaching and education. We want to make sure that we can get them in the lab and get them this experience, because it's amazing for them to get ready to go somewhere else, right? For grad school
Absolutely.
or whatever it is they might be interested in. But that little bit of lab work and research is really nice. They learn those ins and outs, protocols, how to write things, and now
Not
they're famous.
not only that, and in one of the project, my undergraduate my research assistant actually troubleshoot some of the protocols, because we're realizing we're doing when we run two sets of data, we realized that the data was not consistent, and then because we had two operators, and then she and I actually sat down. She was one who noticed what was different during the operation, during the experiment, and then we actually modify our procedure so that we could reproduce the data. So it's really nice that you train them to go through this whole discovery process, problem solving process, and then they actually apply them in real life. So
Yeah, that's undergrads are fantastic. So I
okay.
know mine are right now in my lab working, so they should be. So
Yes.
they should be, right?
Yes,
We'll see.
absolutely.
Yeah. So a little bit switching gears here, because again, you're published and your name is getting out about this. We hear that there might be some coffee producing business firms that might be trying to contact you with some collaborations and things of that nature. Is that true? Like, am I going to be Dr. Nini Rao's colleague and she's now famous because of this and that thing?
Well, I've been contacted by a few startups to mostly trying to understand the cold brew process, because they are trying to design apparatuses or trying to create a beverage that they think it would be palatable to the to consumers, and they want to understand the science behind it. Very often they are very good at the design of the product or the marketing of the product, but they also wanted to confirm the science side. So I'm kind of just doing mostly the consulting work, just to give them some ideas to think about, some literature to look into before they start claiming things they're not supposed to claim. Because I'm very big about, if it's not true, please don't say it. If there's no data to support your claim, please don't say it, because it makes me nervous. So that's number one. The other part I've been trying to do, unfortunately, it was interrupted due to the pandemic. Was I've had growers contacting me, asking me if I can do some testings on their beans, and they provide me both roasted and unroasted beans. And then we're talking about very small growers, and they're shipping their beans to me, and then at no cost, and they just, I just want to, you don't have to publish anything, I just wanted to, if you could give us some information so we could have understanding of our coffee beans, would be greatly appreciated. So far I've got a couple bags from a grower in Indonesia, and so I unfortunately haven't had a chance to test those beans yet, but that will be a fun project to compare their beans with my standard Colombian beans, and then see what's the difference, and give him some ideas about how he can craft his coffee. So
nice. Okay, so I don't have to worry about the fame hitting us and walking through too many cameras just yet. Okay, that's fantastic. So, an important question. You ready?
Yes.
You sure?
Sure.
It's a little personal.
Hit me.
What kind of coffee do you drink?
That is a very good question. I am a very simple coffee drinker, meaning that I drink one kind of coffee and pretty much about it. It's pour over.
Okay.
I study cold brew. I don't make cold brew, even though I have a fantastic cold brew recipe. I don't make cold brew. I use French press in lab. I don't make French press either. Pour over is the way to go. So that's the type of coffee I drink.
Okay, all right. I'm just wondering.
I know.
So, because I don't drink, so
I know. So and not only that, I have a lot of requirements for my coffee. For example, I drink my coffee black because I want to taste the subtleties of coffee. Very recently, I got a bag of Ethiopian coffee from a roaster on the West Coast, and oh my God, that coffee was so light and delicious, and then there are lots of like fruit notes to it. It's just like wine. You serve it hot, and so that's number one. Number two, I don't like to let my coffee sit for too long, so I don't make a huge quantity. I make 1 cup, and then I'll drink it, and then that is it. Actually, that has some scientific basis to it, because a lot of the finer particles in coffee tend to continue to brew, and then make your coffee a little bit like nutty and then burnt taste. That's all those sediments that you get. So I'm picky about that.
Okay, all right. So if my listeners have little coffee questions and things like that, what would be your biggest like tips for them? Like you said, don't really let it sit, right? But anything else, any other tips that you would have for coffee drinkers?
Experiment with your coffee, and because you may have a specific taste compared to what I like, and you may want to adjust your grind to coffee ratio to fit your taste. I would recommend very much and get a scale to start with, so you can get that perfect 1 to 15 or 1 to 17. That would be your baseline, and then from there you could adjust your coffee, the brewing parameters, as we call it, and then you can create something that you like. And I think I saw a question that says something about, why does Starbucks taste burnt?
Yeah.
Well, some coffee taste burnt because they are heavily roasted. What you're tasting are the roasting flavor notes that's generated during the heating, the pyrolysis process. So if you don't like that kind of coffee, I would recommend go to roasters that offers light to medium roast. That will have a much lighter and a sweeter taste. What if the coffee has no taste? What do you mean by coffee have no taste? And very often when you talk about coffee have no taste, they are either too dilute, right? Or they're not tasting the coffee quote unquote taste. And if that's the case, maybe you want to go to something a little bit darker in terms of roast, because some people want that coffee taste, and very often it's that burnt taste.
Mm-hmm. Yeah.
I think there was another question here.
Yeah, so the other question was, do you grind the beans fresh every day or buy them already ground? And I guess that's a really big question, because if are you losing anything if you buy already ground coffee?
You do. The coffee industry tend to recommend you grind the coffee fresh every day, just enough to make a cup of coffee.
Mm-hmm.
So if you go to any of the big coffee cafes and whatnot, they have beans packaged separately, enough for 1 cup, and they will grind the beans right in front of you. And because that's the freshest. If you talk about the chemistry behind it, surface area, when you have a high surface area, chemicals tend to escape much more readily compared to a whole bean where the chemicals had to go through a matrix or maze for that matter to get out. And then it's going to take a while for beans to go stale compared to coffee grind to go stale.
Mm-hmm.
So I would highly recommend grinding the coffee regularly. So you
Mm-hmm.
can grind maybe like a 2 to 3 days worth and then store it in a airtight container. This is what I do, just because I sometimes I don't have the patience to grind my coffee in the morning.
Mm-hmm.
And the other tips I can also offer is that if you are to change beans per se, for example, I just changed my beans from Ethiopian to Colombian because I ran out of my Ethiopian beans. I have a grinder and I clean my grinder so that I don't have that contamination between my Ethiopian coffee and my Colombian coffee, especially if the roasts are very different. So if one's much lighter, the other one's much darker, I would definitely clean my grinder. And my grinder is easy to clean. Some compressed air, you just brush it off. It usually would do the trick. French press versus brewing. Well, that is a personal choice. French press is a submersion method, and if you were to do French press, you may want to consider making sure you don't over brew it, and the temperature of the water should be less than boiling for all of them, pretty much, except for espresso. Other type of brewing, I never like percolator just because the temperature is too high. You have a lot of extraction going on in coffee, make you taste burnt, make you taste metallic. It's just not my cup of tea. But you can make a very lovely French press if you watch for the water temperature as well as how long you brew it, which is really the key. You really shouldn't brew it for more than 3 to 4 minutes. So
nice. So I have one last question, and
yes.
It's more personal because my family is big on coffee drinking, and I don't understand how this works, but you might. So my family's favorite coffee, right, is this blueberry cobbler coffee. How do they get the flavor in the ground coffee? Because they're not adding it later. It's not like it's, something they're adding later. But how do manufacturers put flavoring in coffee? Do you know?
It's not 100% how they do it, and very often it's additive of
Okay.
It's infusion process.
Okay.
So again, I am not big on flavored coffee,
Mm-hmm.
and it's one of the areas where I just cannot answer with with confidence.
I got you. No worries. No worries. When you say cold brew, do you also consider things like iced coffees like fraps and mochas considered cold brew or no?
Difference between iced coffee and cold brew is cold brew coffee is brewed at room temperature. So the brewing process never is always at low temperature. Iced coffee are coffee that brewed hot. So for example, they can use percolated coffee or French press and then chilled using ice or refrigeration. So they are technically not the same. Because they're brewed differently, they will taste differently.
Got it. Got it.
Yes.
Well, nice. So I guess that's kind of it for this particular SpectorCast. And first of all, I just want to thank you for joining us and answering some questions about coffee.
Thank
I
you for
learned a lot
having me.
because I don't know that much about it. So I appreciate you teaching us a little bit about it and telling us about the best techniques and things regarding coffee and what you find in your research. So I can't wait for the next paper to come out. I'm sure there'll be more regarding it as well. So I hope that everyone enjoyed listening to our expert, Dr. Nini Rao. Again, if you have questions and things of that nature regarding coffee, you can always find us on the Thomas Jefferson University campus, East Falls, and things of that nature. So we hope that you will join us for our next podcast. And until then, we just want to say have a good day. Please be safe, and everyone just enjoy the weather outside. So thank you guys. Have a great day.
Thank you, everybody.